A lot of our solutions are going into the 5G. How does the network look? How does the model look? God, it looks like a graph. Let's go again. Let's use them again. So you're going to see a lot more of these deployments in the 5G world and the telecom networks, at least that I'm working in, where we're using a lot of the software solutions to persist the data in a graph model, in a geospatial model, because the dots don't have names. They have lats and longs. And where the network is in a geospatial way, and how you display that is on a geomap. That's how we're doing it. Everything's in a geomap now. Everything's in a geomap. So that's pretty much it. Any questions? See if I get this to go. Oh, performance. I promised performance. I'm sorry. OK. Very interesting mathematical solution, or concept, I should say. It's something called Big O. I'm not sure if people notice this. This is a website. It's called bigocheatsheet.com. I love this page, because it explains clearly and concisely what you're dealing with. This O sub n would be, in a very simple case, I'm an iterative coder, and I write a block of code that iterates one iteration for every record I have in my database. One iteration for every one. So as the data gets bigger, the number of operations that are handled is just that O sub n. If all I do is take that one iterative process and embed it inside another iterative process, I now have two iterations, one dependent on the other, that's O(n) sub squared. This is this guy up here. And you can see as the data increases, what kind of performance I'm dealing with. So in my ideal world that I work in the relational world, I'm O(n) squared all the time. All the time. This is what I'm dealing with every single day, this kind of thing. With the scaling of the amount of data, the 100,000 orders that the data center right down the street does, it doesn't do well in a relational database, because it's O sub n squared, basically. Now, what we've been finding is we've been operating this n log n. That's where we've been working in. We've been working in that kind of number. So when we do performance analysis, we're not going to be down here where you don't have to worry at all about scale. But we're kind of worried about scale, but not to the degree we were before. So that's the kind of performance we're seeing. We're seeing like n log n O. That's, again, a mathematical concept. But I'm trying to show in the graph here that it scales beautifully.
Wait, why do you see that? Is it because the API architecture? Is it the engine?
Honestly, I'm trying to compare a relational database to a graph database. And to use a term I use all the time, it's like taking a knife to a gunfight. Right? It's not even close. The complexity of the data that I deal with in the telecom world, the number of tables and the inner and outer joins, just to be able to answer a question of, there was a steam pipe that blew up on 20th Street today. Does anyone think that maybe they want to know if there's any services that got taken out by that steam pipe blowing up? How would you know? And how quickly would you be able to tell them? If there's a telecommunications fiber optic cable that's there, and it's on the 20s, how close is that to the UN? Is there a bank nearby that maybe the transactions are not going to close today because the services went down? You'd want to know that. And you'd want to know to deploy your technicians to fix the problem where your key customers are. There's something they call a service level agreement, an SLA. We guarantee the service will work a certain way. Guess what happens when we don't do that? We pay them back money. Right? It costs you in the pocket is what happens.
But, I mean, I think a big reason why, and Tom, in my layman's understanding, in a relational database, you got all these tables.
Right.
And you got to create all these joins.
You do.
And those are expensive and slow.
They're very slow. And, I mean, the throughput performance to be determined on the document, but the availability of those developers to be productive in a fairly short period of time. I mean, when we did this proof of concept at first for a major telecom customer, it was like days. It would take us months to do this stuff. And if you guys do the hackathon and you look at some of the community versions of the database and just go through a handful of videos, you could be productive in like a day. I mean, I don't know any product in the world that works that well. It really, really is hard to compare. And I mean, not because I'm standing in front of these guys, but I mean, I know, I've been there. I was there on a Friday night, and they're going, oh, yeah, we don't have to work this weekend. I'm like, what do you mean you don't have to work this weekend? Yeah, we got it all done. Wow. All right, you gave me a weekend off. Thank you, guys. All right? I remember stuff like that, And if you make me work my weekend, I also remember that too as well. Question?
So working the data must have taken weeks and weeks and weeks just to convert it into a format that you can use and load into the database.
Not really, no.
Try to transport it.
No, not really. The data was already in a graph-like way. See, so the model was already in place. So for us mentally to move from one to the other really wasn't that hard. As I was saying to these guys earlier, like migration is my biggest headache right now. And Colin was talking about the tool that they've got to be able to do it, you know, where you can migrate the data over. I probably spent half my time migrating data. It really is an awful world to be in because you have to be so particular about it. And if these guys created a tool that migrates the data easily, then good for them, because I'm tired of doing it myself, you know?
Could you give a quick 30-second of the teleporter?
Yeah.
Yeah, I might stretch in 30 minutes, but very simply, teleporter is both
Yeah,
a
this-
second line tool, it's Java.
I have a questions page.
UI.
There you go. Oh, there we go.
And it just allows you to connect to relational databases and design how you will in imports into MongoDB. And it can do this on an asynchronous basis. You can do this as a one-time import if you wanted to. You can think of it just as a specific but an advanced ETL tool. We have ETL tools, but Teleport is really nice because it supports all the major relational databases you can think of. And you can map it to, if you wanted to, document, but what's really good about it is you can map it into MongoDB's graph. And so the relationships, the SQL type relationships, you can map as graph edges, and you can control all that.
Right.
Specify if you are to.
Yeah, and we started out in the classic, like, oh, we only know SQL, or our folks only know SQL. And then when we started looking at some of the more graph-oriented type of calls, and we realized what kind of throughput we were getting, I mean, those in vertexes and out vertexes and weighted edges, it is just ridiculous how good it is. It really is. And to be able to query a data center, like, I'm sure these guys are going nuts over here on 21st Street. And if this was a graph database, I'm sure they probably got their answers in better part of a half an hour. And they knew exactly where to deploy their technicians. You know, that's good luck doing that with a relational database. It's not going to be possible. You can't get that kind of answer. The reporting alone, the views you have to create and the extends in your database and the replicators you got to deal with, it's crazy. It's crazy. Simple prototyping, get me quick throughput, get me the answer I need, get my data in there, and let me get my job done. That's really where it's going to be. So
Enterprise, you must have an enterprise license.
we do.
You must have relate to Oracle, let's say.
Not even close.
So with Oracle,
Yeah, these guys can probably quote you the prices, but again, I don't want to disparage Oracle and be recorded saying this, but everybody I talk to, they want off the licenses. It's way too much money. They'd rather go Postgres than keep paying Oracle. They'd rather go open source than have to keep paying Oracle these prices. Oracle's got to figure out what's going to happen because the people I deal with they're like, no, you guys got to figure out how we get me off this thing. It used to be if the CTO said, you know, always make the joke, no CTO lost their job recommending Oracle, right? Because it was, you know, even if you were wrong, well, all right, well, we picked the best one out there, right? Who cares that, you know, nothing works and the servers are grinding to a halt and everything is, you know, going in the crapper? You know, I'll just have my developers work the weekend. That'll take care of that problem. So, anyway, that's all. And like I said, I'll be hanging around later if you guys can think of any questions or ideas you want to talk about. Like I said, I'm happy with it. And like I said, these guys invited me to give the talk, and I rarely ever recommend a vendor. And this is probably one of the few times I have. Okay? That's it. Thank you, everybody.